In this lesson, we are going to talk about another property of derivatives, which is called the product rule, which is a very, very powerful method in finding the derivative of a little bit complex expressions. The product rule says that if a function p of x is equal to the product of two different functions, f of x or g of x, or the same function, and f of x and g of x are differentiable functions, then the derivative of p is the same as derivative of f times the function g plus the function f times the derivative of the function g. What this rule says, for instance, if I have p to be x squared, I can write x squared as x times x. So I can say this is function f and this is function g. Then the derivative of p prime, is derivative of function f. We said this is f and this is g. The derivative of x is 1, so 1 times g, which is 1 times x, which is x, plus the derivative of g. G is x again. Derivative of x is 1. 1 times x is going to give you x. X plus x gives you 2x. And remember from previous lesson, derivative of p equal x squared is to bring the exponent down and then subtract 1 from the exponent, which is 2x exponent 1, which is 2x, which is exactly the same as this result. Now we are going to prove that the product rule is correct. The first example says, prove that the product rule is correct. Let's say p of x is equal to f of x times g of x. Then the derivative of p prime, is the limit when h goes to 0 of f of x plus h, g of x plus h, minus f of x, g of x, divided by h. Now I'm going to add the same quantity to the numerator and subtract it. So I'm going to write this one as limit h goes to 0 of f of x plus h, g of x plus h. I'm going to subtract f of x plus h, g of x, and add f of x plus h, g of x. This is going to give me 0 here. And then I'm going to subtract f of x, g of x, divided by h. Now I'm going to break down the fraction and I'm going to write it as limit h goes to 0. The first two terms I can factor f of x plus h. So I'm going to get g of x plus h minus g of x over h. And the next one I'm going to write as limit of h goes to 0 of, you can see that g of x is common, so I'm going to get g of x out, and then f of x plus h minus f of x divided by h. Now the first term I'm going to write as limit h goes to 0 of f of x plus h times limit of h goes to 0 of g of x plus h minus g of h minus g of x divided by h plus limit of h goes to 0 of g of x times limit of h goes to 0 of f of x plus h minus f of x over h. You can see this one is the definition of g prime of x. And this one, when h goes to 0, this goes to f of x. So this is the same as f of x times g prime of x plus this one does not depend on h. When h goes to 0, it still goes to g of x. And this one, when h goes to 0, is the definition of f prime of x. So you can see that we just proved the product rule. The next example says, use the product rule to find the derivative of p of x is 3x minus 5 times x squared plus 1. If I denote this one as f and this one as g, then the p prime is f prime. F prime, 3x minus 5, the derivative is 3, so 3 times x squared plus 1 plus g prime, derivative of x squared plus 1 is, derivative of x squared is 2x, derivative of 1 is 0, so we get 2x times 3x minus 5. Now, if you expand these, we get 3x squared plus 3 plus 2x times 3x is 6x squared minus 10x, which is 6x squared, 3x squared is 9x squared minus 10x plus 3. I can also find the same derivative by expanding the product. So I can say p is 3x times x squared is 3x cubed, 3x times 1 is 3x, negative 5 times x squared is negative 5x squared, negative times 1 is negative 5. There is nothing I can simplify, so I can say p prime 3x squared, 3x cubed, derivative of it is 3 because of the coefficient, times you bring the exponent down, so it becomes 3, and then subtract 1 from exponent, so it's 2. 3x derivative is 3, negative 5x squared, so it's negative 5 times 2 x exponent, 1 less than 2, which is 1, minus 5 derivative is 0. So this becomes 9x squared, negative 5 times 2 is negative 10x, plus 3, which is exactly like what we got previously. The next example asks us to find the derivative of 2x plus 3 times 1 minus x. So we are going to use the product rule. I'm going to say y prime is the derivative of 2x plus 3. The derivative of 2x plus 3 is just 2 times 1 minus x plus 2x plus 3 times derivative of 1 minus x is negative 1. So this becomes, if I distribute the coefficient, I get 2 minus 2x, negative 1 times 2x is negative 2x, negative 1 times 3 is negative 3, negative 2, I get negative 4x, negative 3 and 2 I get negative 1. Doing the same thing by expanding, just to test the result, I get, if I expand, 2x times 1 is 2x, 2x times negative x is negative 2x squared, 3 times 1 is 3, 3 times negative x is negative 3x, which is going to be negative 2x squared, negative 3x and 2x is negative x, plus 3. Now the derivative of this function y prime is negative 2 times 2x, x squared, derivative is 2x, Negative x is negative 1, and 3 is going to give us 0. So the answer is negative 4x minus 1, which is exactly what we got previously. The next question asks us to determine the equation of the tangent to the curve y equal x squared minus 1 times x squared minus 2x plus 1 at x equal to 2. First, when x is 2, the y-coordinate, we needed to find the y-intercept. So the y-coordinate becomes y is 2 exponent 2 is 4 minus 1. 2 exponent 2 is going to be 4 minus 2 times 2 is 4 plus 1. 4 cancels with 4, so I get 3 times 1, which is going to be 3. So the point that the tangent touches the curve is at 2 and 3. Now, to find the equation of the tangent, I need the slope. To find the slope, I need the derivative. So I'm going to say y prime is derivative of x squared minus 1 is 2x times x squared minus 2x plus 1 plus x squared minus 1 times the derivative of the x squared minus 2x plus 1, which is 2x minus 2. Now, to find the slope, I just need to evaluate at x equal to 2. I don't need to expand it anymore. So we say that the slope is at x equal to 2 is 2 times 2 is 4. 2 squared is 4 minus 2 times 2 is 4 plus 1 plus 2 squared is 4 minus 1. 2 times 2 is 4 minus 2, which is equal to 4 minus 4 cancel. So I get 4 times 1 is 4. 4 minus 3, 4 minus 1 is 3. 4 minus 2 is 2. So 2 times 3 is 6. So plus 6 is 10. So this means that the equation of tangent becomes mx, which is 10x plus b. But the tangent has to go through this point, 2 and 3. So to find b, I'm going to substitute 2 and 3 back in the equation. I get 3 is equal to 10 times 2 plus b, which is 20 plus b. I move 20 to the left. I get b is 3 minus 20, which is negative 17. So I get the equation of tangent to be 10x minus 17. The next question says that we have a student council that is organizing its annual trip to an out-of-town concert. For the past 3 years, the cost of the trip was $140 per person. And at this price, there are 200 seats on the train which are filled. This year, the student council plans to increase the price of the trip by $10. And every time they increase the price by $10, there is 5 less students that will attend the concert. The first part of the question says write an equation to represent the revenue R as a function of the number of $10 increases in the price. Without increasing the price, we know that R is going to be number of people who are going to attend the concert times the price per ticket. Price per ticket is $140, and the number of people that they are going to attend is 200. Let's X represent the number of increases of $10. So the price instead of 140 is going to become 10x plus 140. Again, x represents the number of increases of $10. So if x is 0, meaning there is no increase, then the price is 140 as we had before. And since every time we increase by $10, there is 5 less students, So it's going to be 200 minus 5x. So this is going to be our revenue function based on the number of increases of $10. The next part of the question says determine an expression for dr over dn. N here is the number of increases, which in our case we said is x. So dr over dx. We have to find the derivative of our revenue function with respect to x. Going back to our revenue function, r prime or dr to dx becomes the derivative of this 140 plus 10x, which is 10 times 200 minus 5x, plus 140 plus 10x times the derivative of the second function, which is negative 5. Expanding this expression, we get 10 times 200 is 2000, 10 times negative 5x is negative 50x, 140 times negative 5 is negative 700, and 10x times negative 5 is negative 50x. 2000 minus 700 is 1300, minus 50 and minus 50 gives us negative 100x. So this is our dr over dx or r prime. The next part of the question says, what is the rate of change in revenue when the price of the trip is $200, and how many students will attend the concert at this price? We know that the price is 140 plus 10x, and we know that the price right now is 200, so this has to be equal to 200. So from here I get 10x is 200 minus 140, which is 60. So x is 60 over 10, which is 6. This means that at $200 price, there are 6 increases of $10. We know that r prime is 1300 minus 100x. So if we want to know the rate of change when x is 6, we are going to substitute x equal to 6. We get 1300 minus 100 times 6, which is 1300 minus 600, which is going to give us $700. So this is our rate of change in revenue when the price is 200. Now the question is, how many students will attend the concert at this price? Remember that the equation for number of students is equal to 200 minus 5x, which is 200 minus 5 times x is 5 times 6 is 200 minus 30, which is 170 students.